Okay, where is my screen? Oh, there we go. All right, so did this come back a little bit, you guys? Do you remember using the volume formula? Okay, we're gonna look at some different figures today, and we're going to do some problems with the volume formula. And this should be pretty easy for you guys today. This is review. Not that it's not going to get harder, right, in the unit, because it always does. But let's take a look at these solids. And first thing we're going to do is we're going to name them. And then let's just talk about how are they the same and how are they different. So why don't you just talk about, see if you can come up with a name with your table partner first, if you can remember, and then talk about their similarities and differences. Just take about 30 seconds to do that. Okay, what did you guys determine? So what are some ways that all of these shapes, actually, let's do names first. Did anybody remember how to name these? What's one, Elin? Ooh, you got it. Nice job. Rectangular prism. Okay, good. Keep going, Elin. Okay, a cylinder. Sure, that's okay. So we've got a cylinder. You can also call this a cylindrical prism. How about the last shape? What's the last one, Kinsey? It's a triangular prism. Great job. Why do we tack the word prism onto these, you guys? It does sound cool, but there's a better reason. Alex, what do you think?
Because it's in like 3D shape, it's not like a flat circle or a square.
Yeah. Okay, good. So it's it's a drawing on our page, but it represents a 3D figure, right? So if we were to look through this, we would see another shape down here at the bottom that would be the same as the face up here, right? So it has two matching faces at the top of the and the bottom. Same with the cylinder, same with the cube, or the cuboid, I should say, or the rectangular prism. So prisms are named for their bases, and prisms have two congruent bases. What does congruent mean, you guys, in math? What does congruent mean? Mateo, do you have your hand up, or you just like going like this? Okay. What is it, Tyler? The same, exactly. Good. So prisms are named prisms because they have two bases that are opposite each other that are the same. Think about the difference between that and then, like, let's take a look at this figure right here. That's not a good start. Here, let me draw it like this. Would a figure like that be considered? Now this is supposed to be 3D, but you guys will have to forgive me. Would that be considered a prism? No. No, it would not be. Imagine a pyramid. This is a pyramid, right? It does not have two bases that are opposite that are congruent. Okay, it has a base on the bottom and then it has three sides meeting at the top, or another, that would be a triangular pyramid. Here's another shape for you. Let me do this in a different color so you guys can see it better. These are hard to draw, you guys. Would that be considered a prism? No, because all of the faces meet at the top and it only has one base at the bottom. This would be, well, the way I have it drawn doesn't look like a rectangle, but because I was trying to draw it in 3D, but that would be a rectangular pyramid. All right, but we're going to be dealing with prisms in this unit, and prisms have two bases that are opposite that are congruent. Okay, that's how they're named. Now, what did you guys notice for similarities between all three of these objects? Ray, what's one thing?
They're all congruent.
Okay. Are all three objects the same? Well, right here I have a rectangular prism, right here I have a cylinder, and then I have a triangular prism. So they're not congruent. Okay. What did you guys see that was the same? Yeah. Yep. But of what? Yep, they all have a height of 15 centimeters. Good job. So in that way, they're the same, right? How are they different? Tyler? Yeah. All of their bases are different shapes, aren't they? So we've got a circle for a base in the middle. We've got a triangle for bases on the side, and then a squares for a base over here on the rectangular prism. Okay. So let's take a look at this next picture that you guys have in your notes. Did we all get those answers on the bottom? You should have answered same and different on that page, and you should have written down the names for these figures. So what was the same was that they all had a height of 15 centimeters. What was different is that their bases are different shapes. And then make sure you have written down the names of these, please. Okay, let's move on. All right, so looking at these two columns, what is the difference between the two columns? What do we have on the left and what do we have on the right? Austin?
One is rectangle.
Great. So what does that mean for the bases of those figures on the left and the bases on those for those figures on the right? This is an easy question, you guys. Come on. Annie?
One's like
What kind of bases do these figures over here have? Yeah, rectangle or square, right? I'm doing my best to draw here, you guys, but. So these on the left, I'm sorry, I think I said the right, and I meant the left. Those all have a rectangular or square shaped base, right? And then how about Alex, what about on the right over here?
it's triangle and rectangle.
Do I have any rectangle bases over here?
Not the base. It has rectangle bases on one and then.
So the bases in a prism are the two faces that match. So all of these over here, if you look at it, they all have triangular bases. So I know like this one right here, you're looking at that one, aren't you?
And the top.
Right, but those aren't rectangles, those are sides of the triangular prism. So prisms are named for their bases. So what we need to do is look at the two matching sides that are opposite each other, okay? So in this, let's take this first prism as an example. If you were to be able to look behind that face of that prism, the other face would not be opposite of it, would it? It wouldn't be separated by a length. They would meet together like this, right? Okay, but these two faces right here, and then we can't see it, but it would be back here, right? You can visualize that, right? Those are connected via a length that gives a depth, and they are the same. So the opposite bases are the same. So that's what we look at when we are looking at the prism. It's like looking at the faces that are opposite and are the same. Is anybody having a hard time with that at all? Okay, I think you guys can look at those instinctually and be like, yeah, that's a triangular prism. I can just know, right? Okay, so when we find the volume of something, we are finding the number of cubed units within that object or whatever, okay? So when we look at something like this figure that you've got in front of you, now we're on the next slide, and we see a measurement of 15 centimeters this direction by 10 centimeters that direction by 10 centimeters that direction. What that implies is that we've got 15 small little 1 centimeter units going this way, 10 going this way, and 10 going that way. And we're finding the number of those unit cubes in the object. And the way that we do that is with the volume formula. So I bet you guys can already tell me what the volume formula is. Yeah, good. Okay, so this is gonna be very similar to circles in that we're gonna be using formulas a whole lot. Length times width times height. Now, when you look at that formula, we're always gonna answer with units cubed, by the way, you guys. When we look at that formula, oh wait, I don't want that yet. Shoot, you guys already have the answer. Ah, do you recognize a formula within a formula? Nora?
Yes.
Well, yes.
Area.
Yes, so you can find volume of a rectangular prism with length times width times height, but you can find the volume of any type of prism if you can remember area times height. Okay, so just go ahead and let's fill in some values here. In this particular example, we've got 10 times 10 times 15. And by the way, guys, it doesn't matter a whole lot, you know, what order, it doesn't matter at all what order you multiply in, because you can always multiply in any order. So don't get hung up on like, which one's the length, which one is the height, which one is the width, right? At least for sure for a rectangular prism, that doesn't matter a whole lot. All right, who's got an answer? Mateo? 1,500 centimeters squared cubed. Good job. Okay. All right, let's take a look at the next example. If we know that volume equals area times the height of the figure, right? Let's just take a look at that first figure right here. We've got the volume of this rectangular prism over here. And then over on the right, they want you to find the volume of a triangular prism. What would you guess the volume of a triangular prism is going to be compared to the volume of a rectangular prism? Bastian, I would like your eyes this direction. Thank you. Do you think it's going to be a fourth? Is it going to be a half? What is it going to be? Charlie? It's going to be half of that of the rectangular prism. Okay, let's see if that works. All right, so remember volume equals area times height. So in your packets, you already have the volume equals 1/2 base times height of the figure. So this can be confusing right here, right? Because we have base times height of the figure. So the base and the height, remember, this is the area formula for the triangle. That's the area right here. And then the capital H, height of the figure, that is the value that gives those two bases depth. Okay, so that's like how high it is. Remember that the base and the height have to be at 90 degrees to each other. So when you're looking at a triangle, look for this little thing right here. Okay, so right here, we've got the area formula, area, 1/2 base times height of the figure. And so when we plug those values in, we've got 1/2 times 10 times 10, which would be 50 times 15, and that's going to give us 750 cubed centimeters. Is 750 cubed centimeters half of 1,500 cubed centimeters? Yeah. So we just took this half and we got rid of it when we found that triangular prism. How are we doing so far, guys? Okay, pretty easy peasy. Okay, so without thinking too hard, because it's not in today's lesson, how do you think you might find the area of a cylinder? Just using what you guys just got tested on yesterday. How would you find the area of a cylinder? If we're always finding the area of one of the bases and then multiplying it times the height. What do you think, Ray?
Two circles and then part.
The around part, the circumference? Okay, so think again, just think this through, you guys. Remember, volume for any figure is area times height. This is the formula that changes depending on what type of prism we're trying to find the volume for. Mateo, what would be your guess?
Oh, so you would find the area.
Uh-huh. Both of them? Yeah, think about what we just did right here, right? We just found the area of one of the faces. And then what?
And then we multiply it by the height.
Okay, so what would the formula for area be for a circle?
Volume.
Or, I'm sorry, volume, yeah. But what would the formula for area of a circle be? Yeah, pi r squared. So when we're finding the area of a cylinder, then all we have to do is I'm sorry, when we're finding the volume of a cylinder, all we have to do is multiply the area times the height of the figure. So if you can remember this, you can find the volume of anything. Any regular prism. Sorry, there are other more complicated volume equations that you'll learn much later, but not. All right, so let's find the volume of some of these triangular prisms. Okay, so this is the one we're finding right here. So this illustration over here is just to get you to see that this triangular prism is half of this rectangular prism, if we were to fill that in. All right, so we want to start with our formula. 1/2 base times height of the figure. Okay, so go ahead and make sure you fill that in. Area of the base, you should be writing down 1/2 base times height. And then let's fill in some values. Okay, they're giving us one extra value up here to trip you up. So let's make sure we get the right ones. All right, for our line 2, volume equals 1/2 times what times what times what? Remember, the base and the height always have to be at right angles to each other. Okay, so what will I fill in for my line 2? Annie? Yep, 1/2. Yep, 1/2, 3 times 4, that's gonna give me this area, right? And then we want to add in the height of the figure, which is the space between the two congruent bases. So in this figure, it's 10. So our volume formula is 1/2 times 4 times 3 times 10. Why am I not using this value right here? Can you guys see the red, or would you rather that be a different color? About that. Why am I not using that 5 centimeters, you guys? What do you think?
We only need the base, the height.
Yep, we need the base and the height, and then the height of the figure. This 5 centimeters, this is the hypotenuse of this right angle right here, and we don't want to deal with that at all. We need a base and the height that are at right angles to each other. And that's important to remember, because what if you have a triangle like this? Like, let's say we've got, this is 2 down here, this is 3 here, this is 4 here. How would we then find the area of that triangle? Let's say we go back and that's 10. How would we then find the area? What would be the right values to plug into our formula? Gabby? Yeah, so you would need to use this. This is the height of the triangle. The height of the triangle is at right angles to the base. All right, so what's the volume of the triangle, the triangular prism that we found? Elijah? Yep. Cubed, 60 centimeters cubed. Okay. All right, let's do another one. Actually, I think that's the same problem, so let's skip that. All right, go to the next problem. Actually, no, let's not skip it. Let's just go ahead and make sure that we're on the same page in terms of what you guys are expected to write down. So we just did this, you already know the answer. But remember that for that first line of work, you need to do volume equals base times height of the figure. So I want you guys to go ahead and copy down the other lines of work here. So in this particular problem, we've got it. I'm going to write this more neatly for you guys. I don't like the way that the PowerPoint is showing it. Let's do this. Volume equals 1/2 times 4 times 3 times 10. So just make sure you have all of these written down, please. And then you could cross cancel if you want. And then your final line of work is down here. Okay. All right. Go ahead and do the Toyo on the next slide, please. Actually, you have 2 Toyos. Go ahead and do both of them. We'll go over those in just a minute. Let's go over them. All right, can somebody give me the formula for the volume of a triangular prism? Okay, should see like all of the hands go up right now. Caleb, what is it? Great job. 1/2 base times height of the figure. Looks like that. And the reason these are in parentheses is because I want you recognizing that it's area times height. All right, so for this particular problem, Caleb, how did you substitute in the values? What's my next line of work? Times 5 times 15. Nice job. And then we can cross cancel, and we have volume equals 25 times 15. And Kayla, what did you get for your final answer? 375 centimeters cubed. Nice job. Okay, give yourselves a little snap if you got that right. Good job. Okay. Oh, good practice. Okay. All right, let's do the next one. This is the same problem. I don't know why I've got two slides here. Okay. Next one. All right, what's my first line of work, please? Gauge. That's okay. You can give me the first line of work though. And then what? Times height of the figure. 1/2 base times height of the figure. Because remember, we're finding a three-dimensional prism. So we need to multiply area times the height of the figure. Okay, what's my next line of work? Isaac Ring? Okay, times 17 times 4 times 5. Oh, good. I can cross cancel right there. And now I've got volume equals 34 times 5. And what did we come up with for an answer? Liam, do you have it? Okay. Isaac Ring, keep going. Nice job. 170 centimeters cubed. Yeah, way to go. We could do that in our heads. We could do 30 times 5, which would be 150, and 4 times 5, which would be 20, and we could add those together. Mateo.
You can use 34 times 5, because it's an easier way to do it with like 5 by 2.
Well, I tell you what, oftentimes people see things differently. And since we're doing multiplication, it doesn't matter what order we multiply in. So your way might be easiest for you and my way might be easiest for me. Okay. All right, your homework tonight is workbook